This is Performance Time, the show about human beings and performance engineering. I'm Stephen Townsend. Welcome back to Performance Time. Today, I asked the question, to stub our performance testing environments or not? Or another way of putting it could be, do we run fully integrated end-to-end performance testing? Or do we do component-based performance testing? Or both? Or something else entirely? This is a really current and active conversation in the organization that I work for, and that's why I wanted to talk about it today. But let's take a step back, and before I get into the conversation itself, let's just clarify what I mean, what this is all about. So first of all, what is a stub or a mock? Now, I'm sure almost everyone listening will know what that is, but let's just make sure we cover the basics. A stub is when you have a solution with multiple software components, and for whatever reason, you are unable to include some of those components in your performance test or any environment. Now, in the case of performance testing, not having a component can often mean you simply can't run a performance test because it breaks functionality. So what we do is we replace the missing component with a stub or a mocked endpoint. And what that stub does is it simulates or pretends to be the system which is missing, but with much more limited functionality in terms of what it responds with. But just enough so that it unblocks you and allows you to continue your performance testing. Now, I'm grossly oversimplifying mocks and mocked endpoint and the whole process around that, but that's the general idea when it comes to performance testing. So I won't go into any more detail than that at this time. Now, it's worth pointing out that when we think of component performance testing or performance testing in a stubbed environment, it's easy to take your mind straight to, we want to test one system in isolation. But that's not necessarily the case. You could have a mostly end-to-end integrated environment and just stub out one particular component which is unavailable for whatever reason. Maybe it's a third-party software as a service API and you're not allowed to include it in your performance test environment, for example. But another important point is you can do component performance testing which does contain multiple components, and you just draw a boundary around the bits that you want to keep grouped together. So that's an equally valid use of applying stubs to do component performance testing. So where do stubs come from? Who makes them, and how do they come into existence? Well, developers can write their own code to build stubs from scratch. That's one way you could go about it. And it's actually really good practice if you are developing APIs to build stubs alongside the APIs and keep them up to date. That's going to provide a whole lot of value to other teams who include your APIs in their test environments. But there are also tools out there which can help you build stubs, even if you're not a developer. The tools that I'm aware of at the moment are Hoverfly and WireMock, and I know quite a few teams use SoapUI. So that's what stubs or mocks are. So why? Why would we build them? What's the benefit? Well, the first thing is you decouple systems and teams from each other so that those teams can run their performance testing or any testing independently from each other. And that's a hugely valuable thing to achieve. So let's think about a complex solution with many, many systems, and there's different teams working on each of those systems. Now, quite a common situation is that those different teams deliver features at a different cadence. And unless you design your solution in a completely decoupled way, then that means that one team might be waiting on multiple other teams to finish their code before they can deploy into an environment and get an end-to-end environment working. But stubs allow those teams to work independently from each other, so they're no longer waiting for other teams to finish writing their code. So for performance testing, that's pretty huge. It means that each team can run their own component performance testing in isolation whenever they want, without having to book an environment, without having to worry about downstream systems being down in that environment. That's pretty empowering. I think that's a major reason why stubs can be so powerful, is because large, fully integrated end-to-end environments are very complex and can be incredibly costly to manage and work in. So I've kind of just made 2 points really. The first one is that by having stubbed performance testing environments, it can allow your teams to performance test independently from each other. But it also helps deal with the complexity of end-to-end performance test environments, which are even more complicated than regular end-to-end environments because they tend to need to be production spec in terms of configuration, of infrastructure, of data. So reducing the complexity of end-to-end environments by adding stubs can mean that you'll be able to run your performance tests more often because there's less complexity, less downtime due to a component somewhere else not working. It also means that you're probably going to get more consistent results and be able to focus in on the performance of a part of your solution, which is really useful for continuous performance testing, where you might want to run every single day to track the impact of the builds done that day. And another side effect is that if you're using stubs, it might make your load tests simpler because there's less data dependencies, because stubs don't care about what data you send them. Now we'll talk a little bit more in depth about that shortly. The other thing to point out is that stubs provide wide-ranging benefits well beyond performance testing to your organization. They can let you do all kinds of testing and delivery and deployment and operational activity in a simpler way. So, we've talked about the benefits of stubs or mocks in an environment. So let's talk about some of the challenges you might face though. The first big challenge is who is going to build and maintain the stubs or mocks. Now I talked earlier about how teams that deliver APIs, it often makes sense for them to build the stubs or the mocks to keep in alignment with the contract of those APIs. But that's not always the case. API teams don't always develop mocks. Sometimes the team who consumes the APIs builds the mocks themselves. And then again, sometimes the performance engineering team is asked to build the stubs or the mocks. The question is, who's in the best position to do it? And how much time is going to be required to maintain the stubs or the mocks so that they continue to work as the API contracts change? Now, in the real world, you'll probably find that nobody wants to build the stubs unless it's built into their DNA or the culture of the way that team works, because it takes additional time away from delivering features. It's a long-term commitment to the organization to keep these mocks up and running and maintained. Now, sometimes stubs, they respond immediately with that mocked up response. But in many cases, and especially in performance testing, it's good practice to add a delay so that the system which is calling the API will have to wait for a short amount of time, just like it does in the real world. Now, as a performance tester, this can introduce a particular challenge, which is how do you remove the stub delay from your load test results? Because you don't necessarily want to see the response time including the stub delay. You want to know specifically how long the application under test took. And it's particularly complicated if each of the different stubs that you have has a different delay. If you're using the out-of-the-box analysis that comes from your load testing tool, it's probably not going to provide you anything to help you in this situation. I think that's a good segue into talking about what are some of the drawbacks of performance testing in a stubbed environment. The first one is that there are some performance issues which will be harder to catch using a purely stubbed approach, because we can't always predict or simulate accurately the way in which different systems integrate together, especially really big complex systems of systems. The second thing is you won't be definitively capturing the end user or customer experience with one load test. You'll need to use alternative approaches to get that. For example, using APM tools in production or leveraging your automated functional testing, but both of those have drawbacks in different situations. One way you might go about it is to take the response times from a series of different component tests and add them together to get an idea of what the end customer experience might be. But there's a whole bunch of mathematical reasons why that doesn't necessarily make sense and it's not necessarily accurate. Not the least is that systems don't run sequentially. Things happen in parallel or there's asynchronous activity. It's very easy to get something wrong and make a mistake. I think the really tricky thing with all of these approaches is you need to get some results which your stakeholders, whether it's the business or executives, will see and understand and be comfortable with. And I think that's another drawback. When you start doing component performance testing and you're slicing up bits of the solution and maybe you're combining different times together or taking timings from automated functional testing without so many samples, it can be hard to win your stakeholders over to accept those results. There's just something about the grand end-to-end integrated performance test which some people just want. And that's another potential drawback. It can be difficult to justify spending time on component performance testing if you're already planning to do end-to-end performance testing later anyway. You might get asked, well, why am I going to spend time and money and resource to do this component testing when you'll just catch it all in end-to-end anyway? Which misses the entire point that the component testing serves a different purpose. It's going to find performance issues earlier in each system. It's going to provide a clear view of how each system is performing and changing over time. It's going to take the pressure off that incredibly costly and complex end-to-end performance testing cycle that might happen later on. It's also going to provide delivery teams a much higher chance of being able to do their own performance testing because it takes away all the complexity of the other components which are outside of their area of expertise and add a bunch of complexity to the environment, as I talked about earlier. Okay, so before I go into some suggestions about how we can potentially make stud performance testing work in our organizations, there's two things that I think we need to be careful of. The first one is, if you have stubs in a performance test environment, they need to have delays. You can't have stubs which just respond instantly, because that's not what happens in the real world. And there's a very common type of performance issue where a consuming system has to wait for a long time for a downstream system, and a bunch of queuing occurs and weird stuff starts happening. So one thing you could do is try and make sure that the stubs that you create have a delay which roughly matches the actual service time in a real integrated production environment. And another thing you can do is to configure your stubs to have a particularly high delay, maybe a minute or 30 seconds or something, just to see how the consuming system behaves when you have that kind of delay under load. Bottom line is, if you don't have delays in your stubs, you're going to miss performance issues. The risk is too high. Another challenge, which I think I've talked about in a previous episode, is the diversity of the test data that comes out of your stubs. Many stubs just return the same response every single time, and that might be okay, but it can cause issues. I think the example I gave before was that what if you had a stub which always returned the same vehicle every single time, and you were creating customers that had this vehicle, but then it turned out that you could actually search for customers by the vehicle, and that might cause a false positive database performance issue. At the end of the day, if you're not careful and you use stubs in your performance test environment, you could be filling up your application database with unrealistic, homogeneous data where all the records look the same, and that takes away from the realism of your tests and the accuracy of your testing. So the stubs in your performance test environment might need to provide quite a diverse set of data, maybe randomized data, in order to avoid this situation. I've actually thought of a third thing to be careful of, and that is that when you report your performance test findings, when there has been stubs involved, you need to be really clear about what it is that you're reporting, and that you have included stubs, and whether or not there are delays, and what it is that those numbers actually mean. Otherwise, they could be misinterpreted, and things could get a bit hairy. Alright, so I have some suggestions now, But I feel a bit funny about giving them because I am still in the middle of negotiating how much stud performance testing we do, how much end-to-end we do, what makes sense for us in our organization. So let's just say this is where I'm at right now. The first one, and maybe the most important one, is that stubbed or component performance testing is not a replacement for end-to-end. It can definitely lessen the amount of end-to-end performance testing that you need to do, which is a great thing, but it needs to be supported by some kind of end-to-end customer benchmarking. Now, it's entirely possible that in your organization, you can get away without doing end-to-end performance testing. Maybe you've got a software system. It's already in production. You have a very mature delivery process. You're deploying small changes every day. Maybe in that case, depending on the business criticality, you could get away with just using APM and observability tools to monitor the customer experience in production. You could do canarying, for example. But in many situations, that's just not possible, especially if you're introducing a large amount of change or a brand new system where you don't have production metrics to go to yet. My current motto is to do predominantly component-based performance testing to check the performance of each platform or system, and then overlay that with a thin layer of end-to-end performance testing, which focuses on that customer experience. But of course, it entirely depends on your context and what you're doing, the maturity of the delivery, the maturity of the delivery teams and how engaged they are in performance, how much monitoring you have. Ultimately, it's your call. It's up to you to decide what's an appropriate level of performance testing to do to cover the risk, but in a way which is practical and not impossibly costly and complex. The second thing I need to say again is that if you are using stubs or mocked endpoints in a performance testing environment, they need delays. Otherwise, you are going to miss performance issues relating to queuing. Like I said, a good test to run is to put ridiculously high delays on your stubs, like 30 seconds or a minute or 5 minutes, and just see what happens. You might shake out some critical performance issues which would sting you later. If you want to try and do a almost entirely stub performance testing approach, then think about how much you can do in production. You might want to think about running performance tests in production daily. Might be possible, it might not. You might want to think about APM and observability and getting the most out of it. And what I commonly see is that that kind of observability tends to focus too much on technical stuff, like how many requests entirely came through, and not enough on the actual customer experience from a step-by-step level. You might want to also consider real user monitoring, coming back from the browser, synthetics, and then different deployment approaches. Can you do canarying so you can deploy changes to a subset of your users or customers without incurring so much risk? All of these things that we can do in production mean that we are reducing the risk of actually impacting our business or our customers. I think that frees us up a little bit to be a bit more creative or innovative in the way that we do our performance testing because the risk is much lower. We're not trying to set up our performance testing as this perfect net which catches every single performance issue. My next suggestion is that stubs should ideally be maintained and owned by the teams who build the APIs. By maintaining the stubs alongside the APIs, they stay in sync. There's no other team who's better positioned to do this. I would say that if you're a performance engineer, then don't get in a situation where you own building and maintaining stubs and mocks. I mean, if you really want to do it, go ahead, but it's going to end up being a full-time job and you're probably going to do a lot less performance engineering. And that's probably not why you've been hired. You have a skill set. It's not the best application of your skills. The last thing is, and on the flip side here, if you're in a situation where it's being dictated to you that you will do full end-to-end integrated load testing, and that's the way it's going to be, then make sure you clearly communicate what it's going to take to make that succeed. All the things required to make sure the environment is up and stable and working, and all the teams that have to be involved, what it's going to take to get the data aligned between the different systems, the different teams you're going to have on call as support, the extra complexity to build and maintain the load test suite and all the different data pools. It's really tricky and complex and costly stuff. The more component testing we do, and the more things we can do in production to understand the customer experience, the less we rely on this one big bang integrated end-to-end performance test to catch all the risk and answer all the questions. And that means we can reduce the scope of end-to-end performance testing to something which is manageable, practical, but still answers the questions which we can't answer any other way. That's all from another week of Performance Time. Thank you for tuning in, and for those of you who've been joining in our conversation on LinkedIn. Coming up, I have some interviews which I'm really excited about and looking forward to sharing with you. And as always, this is Performance Time.